can have a laundry list of those. Everything from major system changes to what does it mean when you take that slab all the way to the perimeter versus cutting it off and stuff like that. I've been very fortunate in this industry, having done this, that you really, through this process, learn the interactive impact of decisions. How glazing affects system, how lighting affects load, how changing this control affects this building in this climate, how reheat is so important in Florida when you have a hospital. You know, things like that, and supplier reset. How little things matter, what doesn't matter, and you really understand the synergy of the building as a whole. The idea that we're going for here is that the thing is self-sufficient. You know, there's always going to be human involvement here, but the more in design we can build in to be simple, straightforward, the more effective we're going to be in terms of performance. So when you see technologies like chilled beams, right? Oh God, it can't work in a climate like this. Simple, controls are simple, no fans, it's uniform. You know, we can't be afraid of these technologies, and I think we're going to start to see some stuff come out, and also the cost benefit from the development side as well, like more usable square footage for some systems. You know, less ductwork, smaller ductwork, less is more. Something that I think is really important. We always talk about load. What's the building load? Well, it's 100,000 square feet, 350 square foot a ton. We're going to need this chiller. Well, let's go beyond that. Let's actually look at the operational load. We've seen on a lot of projects where that load doesn't change from that early concept very much to the actual eventual design. Glazing's changing, lighting's changing. The load and the capacity of our system should change as well. When I talk about operational load, I'm talking about, you know, how the building actually operates. So when you're doing design loads, or when an engineer's doing design loads, they're putting in 3, 4, 5 watts a square foot. That'll never ever be the case, so that they're more than covered, right? We need to be covered. But how does that building that's oversized now function in this range? Have we lost opportunity? Have we gone above and beyond the expense that we could and save the project money and actually save energy as well? So looking at the operational load, how much of the building load is infiltration, lighting, you know, the roof conduction, the wall conduction. When you actually sit there and think about it a little bit, you start to realize, you know what, once we get R20, it's not that much better when we got a 20-story building with a small roof area. You know, we really want to focus on, you know, the heating and solar conduction, because we've got a lot of slab-to-slab glass. Where's my energy going? I talked about that. Accurately modeling measures. When do we see diminishing returns? I've got a couple examples of that. You can't keep doing something before it starts to peak out in terms of cost and actual performance. Integrated building impacts. We talked about that. What if we change this? What if we improve this? What kind of impact does it have? Impact. You hear me say that over and over again. How much impact does the shell have? Well, once you get to a code level, it starts to get less. Now, in our current climate and the current competitive market, what are we seeing? Floor glass, right? It's kind of counterintuitive to energy performance, but that element is going to be there for the next 50 plus years, right? That's a fixed thing. So when you talk about daylighting, when you talk about things like that, when you're really looking at the envelope, the design of the building, you focus on making that thing stand the test of time, both in terms of performance, views, daylight, comfort, you name it. Because the technologies within the building are going to change. Shoot, by the time the thing gets built, the lighting's probably already outdated. Again, it assumes perfect operation and sequence. It assumes the building's operating perfectly all the time. It assumes a sequence of operation is in play. That never happens, ever. Change in time of use. You know, we model typical loads. We assume it's going to be off at 5 p.m. or 6 p.m. You know, we've done a couple models recently where, you know, the operation alone, when we tried to, was the difference, and it took a while to figure that out. That, oh, it is running, you know, longer, or you know, what is the tenant doing? We designed a building for a typical office load, but you got a data center on one floor. So, you know, that's the limitation. Now, when we do M&V, we come back and we kind of tweak those things, and that way we can improve our systems. When to start? Ideal, typical, I actually think somewhere in the middle is probably appropriate at this point. Typical, and this is actually, I think, a bit aggressive in terms of typical. We don't do anything at pre, we don't do anything at SD. We do something at the end of DD occasionally. To Dan's point, oh, we've got the building design, how many lead points do we get? Oh, I need a model. Then the answer becomes, or the question, how do we do? You know, and you're fine-tuning measures. Now, certainly we do a lot of this, but we try and creatively look at like spec items, things as much impact as we can have that late in the process. So the question becomes, from those of you that are consumers of this product, how do we do? What do we get? The ideal, you know, you're going to be looking pre-schematic, form studies, orientation, massing. Obviously, this doesn't apply to all projects, and some of those things you could probably strip out if it's not needed. SD, you can have the most impact. That's when you're looking at systems, life cycles, big picture. You get owner feedback and input, envelope construction, shading. You can talk to the end user and their history of a particular system and get really an understanding. So at the end of the project, the person that's operating the building is aware of why that decision came about and why it's important for that particular solution. Usually at the end of SD, you have a system selected, you're looking at a couple different options. So you take your system you've chosen, your building, and you're trying to optimize that through controls, technologies, modifications. You're looking to incorporate more detail, operational improvements, and you're also giving feedback to everyone in the organization. In organization, I mean the design team and ownership, of where we are, where we're going, so that they can make decisions either way. And then at the end, looks like we met our expectations, looks like we exceeded them. There's no missing, we don't know where we are, it makes sense. We've communicated that message, and I think I really want to get to some of these examples because there's a lot of projects where we flip-flopped in performance, but it wasn't because of the analysis, it was because of the lack of understanding of how critical little tiny things were in a building, so the results were going like this, and I've got a good example of that.